Hello, welcome back to MA211. Let's go ahead and start talking some more about ODEs. I'd just like you to think hard and think of one solution to the ordinary differential equation y prime equals t squared. So that is, you're looking for a function y whose derivative is t squared. Can you think of such a function? Well, if you think hard about it, you might think, well, the derivative of t cubed over 3. That is most certainly t squared, and that's correct. Here's one solution is y of t equals t cubed over 3. But if you've taken Calc 1, and you all have, you also know that, look, the derivative of t cubed over 3 plus 1, that's another solution. And t cubed over 3 plus 43, that's another solution. Okay, in fact, there are infinitely many solutions to this ODE. Infinitely many. Okay, so let's just keep that in the back of our minds for a minute. Can you think of a solution to the differential equation y double prime equals 6t? So you're looking for a function y whose second derivative is 6t. Well, if you think about it for a minute, you'll find that y of t equals t cubed. That's one solution to the DE. And y of t equals t cubed plus, say, 11. That's another solution to the DE. That constant term isn't going to matter because as soon as you take one derivative, it's gone. And in fact, there are other kinds of solutions. So y of t equals t cubed, that's the part that'll matter, plus 4t, right? This linear term will be gone as soon as I take two derivatives, plus, and then any constant I like, that's another solution, right? So I can add on any linear term I like and any constant term I like, and I'll still get a solution to the differential equation. So once again, there are infinitely many solutions to the differential equation. Infinitely. So what we should be taking from this is that if someone says solve a differential equation, well, there are actually infinitely many solutions to a differential equation normally. Okay, so let's carry on a little bit. Like I said just a second ago, there are infinitely many functions that'll solve a given differential equation. Now we obviously can't list them all off, so what we'd like to do is describe the solutions to a differential equation. So a description of all the solutions to a differential equation is called the general solution to the differential equation. And that's not so much a function as it is a description of all the functions. So remember, the solution to y prime equals t squared was y of t equals t cubed over 3, and then any constant I liked here. So I'll write a plus c. Now the plus c here indicates that as soon as I put any number I want in for the c, I get a function, and that function is a solution to the differential equation. Okay, so this general solution means two things. One, any choice of c gives a function. That's not what I want. Close that. Gives a solution to the ODE. And two, any solution to the ODE is in that form. So it means it is definitely t cubed over 3 plus c for some choice of c. Okay. In this case, c is called a parameter. You can choose it any way you like. You still get a solution. Okay, what's the general solution to y double prime equals 6t? Well, if you recall, it was y of t equals, you had to have t cubed, you couldn't have 5t cubed or something like that, but you could have any linear term you like here, so I'll put c1 times t, and you could have any constant term you like here, so plus c2. That's going to be the general solution to this ODE. Any choice of c1 and c2 will get you a solution. Okay, and both of those, c1 and c2, are parameters. All right. Why don't we find the general solution to y triple prime equals 1? If you think about it carefully, you'll find that y of t is going to be 1/6 t cubed plus any quadratic term I like, because taking 3 derivatives of it will kill off the quadratic. So c1 t squared plus any linear term I like. So c2 times t plus any constant term I like, plus c3. Okay, so let's look back a second. The general solution to y prime equals t squared had one parameter in it. The general solution to y double prime equals 6t had two parameters, and the general solution to y triple prime equals 1 had three parameters. So we might guess that an nth order ODE has an n parameter family of solutions, and that's correct. Okay, and that turns out to be correct. So in the future, if you are solving a second order differential equation and you're finding the general solution, you should definitely come up with a two-parameter family of solutions. If you're solving a third order differential equation, there'd better be three parameters in your general solution. If there's not, then something's amiss. Okay, so let's continue just a little bit further. We want to talk about initial value problems. Now remember, if I look at a given ODE, say y prime equals 4y, then there are probably infinitely many solutions to that. And indeed there are infinitely many solutions to that differential equation. Initial value problems add another condition to the ODE. So in this problem, we're saying solve the initial value problem. That's an IVP. And what we want to do is find a function y of t such that y prime equals 4y, so it satisfies that differential equation. There are infinitely many functions that do that. And now we want to pick out one of those functions that has the property that the function evaluated at 0 is equal to 3. This condition is called an initial value. Okay. And we can do that. Solving initial value problems is not particularly difficult once you have the general solution to a problem. So suppose I tell you that the general solution to y prime equals 4y is y of t equals a, any constant I like, times e to the 4t. Can we solve the initial value problem from this? Think about it for a moment. Well, if you think about it for a moment, you know that if y solves the ODE part of the problem, then y of t is definitely some constant times e to the 4t. That's what the general solution says. It says any solution to the ODE is a e to the 4t for some choice of a. Okay, now we just have to choose a so that when I plug in t equals 0, I get out the value 3. So what we want is we want 3 to be equal to y at 0 and that's going to be whatever the constant is times e to the 0th power, so that's a. So if the member of the family of solutions that satisfies y at time 0 is 3 is the solution to this initial value problem, and the solution is y of t equals 3e to the 4t. All right. Okay, so let's move on a little bit. Suppose I tell you that the general solution to y prime equals 4y plus 6 is y of t equals e to the 4t plus 6, a e to the 4t plus 6. Okay, can you solve this initial value problem? Think about it for a minute. What would you do? Well, again, all you want to do is find a so that y at 1 equals -1. So what you want to do is this. You want -1 to be y at 1, and that is a times e to the 4, right? I plug in time 1 plus 6, so that means that a is e to the -4 negative times 7, like that. Okay, that's a strange way to write it, but that's correct. Okay, so our solution is, the solution to the IVP is y of t equals this a, so -7e to the -4 times e to the 4t plus 6. And you could definitely simplify that if you liked, but you don't really need to. Okay, one more. Suppose that I tell you that the general solution to the ODE is this. Y of t is a times cosine t plus b sine t. Can you solve this initial value problem? Well, yeah, sure you can. Again, you just want to choose a and b now. Now there are two parameters in your solution. That comes from the fact that this is a second order differential equation, and you have two conditions that you want to meet. So what do you want? You want one to be y evaluated at pi, and y evaluated at pi is going to be a times the cosine of pi plus b times the sine of pi. And that's just -a because cosine of pi is -1 and sine of pi is 0. So you can see that a is going to have to be -1. All right. Now, what's the other condition that you want? You want 2 to be y prime evaluated at 0. Now let's take the derivative and plug in 0 in two separate steps. So that'll be -a sine t plus b cosine t evaluated at t equals 0. And so that the a part goes away, and that's just b. So we can see that if we're going to satisfy the second condition, we have to have b equals 0. So now we know our a and our b, and we can say that the solution to the initial value problem is y of t equals negative cosine t plus 2 sine t. All right, and that's really it. Once you have the general solution to an ODE, finding the solution to an initial value problem is really not very hard. It's just a matter of choosing those parameters so that the initial conditions are met.